Warning, the video you're about to watch contains mathematics at the level of college algebra and trigonometry. All material has an assumed prerequisite of both Algebra 1, which is elementary algebra, and Algebra 2, which is intermediate algebra. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, Professor of Mathematics at Cosumnes River College in Sacramento, California. This video is a second video in the series on the law of sines, and we have just introduced that theorem, the law of sines, and proven it. Before we go into examples, I want to go into an investigation of the ambiguous case of the law of sines. And I have a link here, and before I go to the link, I just want to showcase what you would normally do when working with a law of sines problem. Now I'm sort of jumping into my next lecture very quickly just to showcase the mindset that I have when I do a law of sines problem. So somebody will hand us information about a triangle, or they might even sketch a triangle for us, but more than likely they'll just hand us information about a triangle and tell us to sketch that triangle and then solve the triangle, which means find all the angles and all the missing sides. The first thing that I do is I actually just draw out a very long horizontal side, as you can see there. And then I use one of the given angles. So they gave me a 29-degree angle and they gave me a 100-degree angle. I just use either of those. It doesn't really matter which one I use. I'll go ahead and use the larger of the two angles just because, well, it might look better if we do that. So I'm going to open up an angle through 100 degrees. So there's 90 right there, and I'll go an extra 10 here. So this will be roughly right there, a 100-degree angle, and I'll just go ahead and open that up. And the side opposite that angle is going to be 115 whatever units in length. Now you likely notice here, when I did this, I actually measured out the 100-degree angle and I labeled that angle. The opposite side is going to be side C, and they told us that's of length 115. And then I just assumed that this angle right here was the other given angle, and that's pretty typical. You generally reserve that angle for the ungiven angle. Okay, so here that angle B was given to us to be 29 degrees. And from that information, actually, you could draw out the triangle. Oh, and I should mention also, I always draw my horizontal side a little too long. That way I could erase off what I don't need. So again, I just want to reiterate, I draw a horizontal side first, and then if they give me a couple angles, I just choose the larger actually, and I open up an angle from the horizontal to the side, and I make that the larger angle. With the law of sines, they're always going to give you at least one angle. So if they give me only one angle, well, then I draw my horizontal side and I open up whatever angle they told me to open up. Okay, and then whatever that side that is labeled, in this case, or whatever that angle is labeled, in this case it was angle C, opposite that angle will be a side length, hopefully, that they hand me. And generally with the law of sines, that's what they're going to do, but they don't have to. Now, to be honest, that drawing, I rarely actually do. I only drew that because, well, I'm instructing you on this, and I was told to do this, right? So I was told to draw or sketch that triangle. But in reality, how most of us will be doing this is we will make a table of angles and a table of side lengths. And you can see it right here. I have a column of angles and a column of side lengths that I haven't filled out. And then I'll just fill in the ones they've given me. So angle B they gave me was 29 degrees. Angle C they gave me as 100 degrees. And side C they gave me as 115. At this point, a student who has gone through trigonometry would know that given this table for a non-right triangle, that they would use law of sines. And the key to knowing that you're going to use the law of sines is the fact that you have a complete row. Once you have a complete row, you know law of sines can be used, because remember, law of sines says the following: side C is to the sine of angle C as side B is to the sine of angle B. Notice in that equation, we have 1, 2, 3 items. So we're only missing the fourth, which means we could totally find that fourth item. Also, you happen to know there's only 180 degrees total in any triangle. Doesn't matter if it's right or obtuse or scalene or whatever. Any triangle has only 180 degrees in its internal angles. So therefore, we also know that this missing angle can be found by taking 180, subtracting off 29, and subtracting off 100. And that should give us around 51 degrees, as I recall. So that'll be 51 degrees right there. And I draw the stuff that we compute, I draw that in blue, just so that we know that was not given to us. But now that I have that, I can easily find angle A, because I can compare, again, just like I compared side B and sine of B to side C and sine of C, I can compare side A to sine of A, or side A over sine of angle A to side C over sine of angle C. So I just want to start with that. I'm not going to complete this problem. I'm just starting with that so you know how I normally would start a problem in a law of sines. So I don't normally draw things out. However, the ambiguous case, the one that we will be dealing with quite a bit with law of sines, causes a bit of a frustration. Now remember, somebody's going to come in and they're going to hand us 3 pieces of information, generally, with the law of sines, or actually law of cosines. They'll hand you 3 pieces of information. They're either a side and 2 angles, or an angle and 2 sides, or they might hand you 3 sides, something like that. And so once you have 3 pieces of information, you can actually find what that triangle is, or with one ambiguous case, you might end up finding that there are 2 triangles or even no triangles that fit that order. So let me give you an example of what I mean. Somebody comes in and they say, hey, the angle A is, I'm just going to make up an angle of 40 degrees. Okay. And then they tell you, the side opposite that angle, well, that's of length 10. And then another side, which I'll call B, is going to be of length, I don't really care, let's call it 12. All right. In that case, I always draw a horizontal line. Actually, in all these cases, I draw a horizontal line. So here I go, drawing my horizontal line. I usually draw it a little too big, whatever. I make a 40-degree angle, and you don't actually have to make it exactly 40, but I'm just doing that because I have a ruler that can do it. And so I do a 40-degree angle. There we go. And you don't even need to make it that long if you don't want to, but I'm going to label that side. Give me a moment while I turn off my ruler. Label that angle as 40 degrees. And we know that the side opposite that angle is of length 10. I'm not going to draw that side in yet. Instead, I'm going to say this side that I've drawn here, I'm going to call B, that'll be of length 12. I will concretely say that's of length 12. I don't know what this side length is. I have no clue. That's side C. But now I'm going to go ahead and draw in, or actually pretend like I'm drawing in, an angle or a side opposite this called side A. Now let's just pretend that this was the side A. If it was that short, you could easily see that it will never touch the horizontal side. So being that short, if that side length is too short, we'll never get a triangle. On the other hand, if they make that side length just long enough that it swings a little bit, let's say, I'm just going to see if I can pivot that there, that it swings a little bit and it just barely touches right when it goes vertical. Then I have, so let's just say the side length is that long. So it barely touches once it goes vertical. That's it. Then I have one triangle and it happens to be a right triangle. If, on the other hand, the side length is long enough to swing down and hit here to create a triangle, yet it's still long enough to continue to swing and come up on the other side to create yet another triangle. See if I can get this as accurate as possible, except I'm missing the mark because this thing's hard to control. I'll just do it like that. Then we'll have two triangles. We'll have this big triangle right here, and then we have a different triangle right here. So we have two triangles, and that's a possibility with the law of sines. You can get two triangles. And then there is the possibility, let me back off on this a little bit. There is the possibility that our side length is really long here. So let me just say it's this long. Okay. So when it swings down, it connects and creates a triangle. But if it keeps swinging along, it'll miss. It won't be able to create a second triangle. It'll just be too large. So we can have three possibilities of types of triangles. We can get a single triangle, or we can get two triangles, or we can actually have no triangles. Now I'm going to go ahead and visualize this with that Desmos application. So here I am in Desmos right now, and this angle right here between the positive x-axis and that blue line, that angle is 40 degrees. So you can see if I raise the angle, it grows and whatever, right? So I'll just keep it at 40 degrees there. I'm saying the adjacent side, that blue length, is 12, of length 12. And then I'm saying the side opposite that, you could see it's in blue here, but it's actually supposed to be able to swing. I don't know why this person didn't code it for that, but you should be able to swing this. The reality is there is some line dangling there that is kind of waiting to strike the horizontal axis. But you can see if the opposite side is too short, 2.88, it's never going to touch this horizontal side down here. If you grow the opposite side and you continue growing it, at some point it'll be just large enough to create a full right triangle. Now, the way this has been coded, it doesn't have fine enough detail, so maybe I should go by a step size of 0.01 or something like that. Oh, it won't let me. That's unfortunate. 0.01. There we go. And let's see if I can make it a little bit finer. No, it won't let me. It only does by 0.1s for some reason. All right, not a big deal. But you grow it just a little bit past 7.6, and it will actually strike the x-axis there and create a triangle. You get a little bit bigger than 0.6, and all of a sudden that side length of 8 is long enough to come swing down and strike here, and so you have this one larger triangle. But then if you let it swing even further, it'll come back over here and create this other smaller triangle. And if I increase the side length, I still have a lot of triangles. Like here's a side length of 10. You can see that with a side length of 10, this black edge over here would swing down and strike and give us a big fat triangle. But then swinging underneath, coming back to here, it gives us a very thin triangle as well. So we have two triangles in that case. But if you make it too large, then it's, in this case, let's make it a size 13. There we go. When it's of length 13, this opposite side, it'll swing down and strike this edge right here to create a very wide triangle. But then if it keeps swinging and it comes back around, it won't be able to strike the x-axis on the right-hand side of the origin. And so it doesn't make another triangle in this area right here with this 40-degree angle. So that is the idea behind the ambiguous case. You could have one triangle, which is this case right here, or two triangles, which is this group of cases right here. There is actually one rare triangle right here where it strikes when it's just long enough to strike the x-axis and it creates a right triangle. And then you could have no triangles. Now, mathematically, how would you determine that? That's the big question. How would you figure out mathematically that you have 0, 1, or 2 triangles? There are a lot of ways that you can go about doing this. But I find that most students don't really, they memorize away and they don't really understand the theory. And as I've taught trig so many times, I can just say it's much easier to follow my advice about building a table. So what I'm going to do when we move forward here is I'm going to mention how to figure out the ambiguities when we build a table of values. It's just something that you need to note here. The three cases really compress down to this. Somebody comes in and they hand you an angle and a side opposite that angle. Well, the side opposite the angle is too short. Let's just say A was 1, right? That side is too short. It's just going to swing here freely in space. We don't know what this angle is, so that's why I'm saying that side is allowed to kind of swing back and forth because we don't have that angle anchored. We have no idea what that angle is. So this side is just going to swing back and forth here, but it'll never touch the horizontal side, so we'll never create a triangle. So this is the case where you have no triangle. And then the second case, and by the way, this is all about what we call the altitude. So if you're really concerned about learning the behind the scenes mathematics here, there is an altitude here we would call h. And the point here is if your side A is less than h, then you don't have a triangle at all. So if that missing or if that known side A is less than the altitude of your triangle, you will not get a triangle. So somebody's handed you an impossible situation. If on the other hand, that side they hand you that's opposite your angle A, so side A, if they hand you a side A that's just long enough so that when it swings, it only connects briefly right here to make a right triangle. That is, A is equal to the altitude h, where this guy right here is the altitude h. Then you have one triangle. One triangle. Again, that's when your side length opposite your given angle A is equal to the altitude h. And then, what if they continue to grow that side opposite side angle A? So opposite angle A, let's pretend the side length is this. I'm going to draw it in blue. So I need blue ink here. I guess that's my blue ink. So we have this side of this length, and it's allowed to just swing down here, and it'll connect right here. And when it does, it creates a triangle for us. Yay, right? We get a triangle. Remember, there is a hidden little altitude that we rarely even draw in here, but I'll go ahead and draw it in just to showcase. We do have an altitude. I'll draw that in brown, just like I did a moment ago. So we have this altitude h right here, h. Okay. But then when you keep swinging this edge here around, oops, sorry, when that's in there, when you keep swinging this around, it'll come back up and connect right here to create a secondary triangle. So this is where you get two triangles. When I say secondary triangle, I don't mean that it's this blue triangle right here. I really mean you have one triangle that's really narrow, this triangle right here, and then you have a second triangle. That's actually your second triangle, technically speaking. And then you have the original triangle, which is, I'm going to use blue for the original, all of this, including this. That is your original triangle. So the green region now, because yellow and blue make green, the green region is the smaller of the two triangles, and then the blue plus green region was your original triangle. So you have these two triangles, the blue plus green, and then just the green. All right, so that would be the two triangle case. Two triangles. I guess I pluralize that. Don't need the hyphen or the apostrophe, but I still have it. In this case, notice, by the way, that the side length A here is longer than H. So A is greater than H, but yet it's not as long as side length B. So this is the case where side A is greater than H in length, but less than side B in length. And then finally, we have this case where our side length is actually, and it's so long, by the way, I actually need to draw in the rest of this horizontal side. So let me just do that really quickly. Just draw this in, just like that. Okay, so in this case, they've handed us a side length A that is so long that when it comes down, it strikes the horizontal axis right there, but it continues to rotate around and it can't restrike the horizontal axis. It just can't come back to it. Notice in this case, that side length A is actually greater than B. This length right here is side length B, and we have a little bit more to get to a length of A. So A is greater than B. Those are kind of the theoretical constructs of the ambiguous case for the law of sines. When in use, though, it's actually not terrible. It just looks bad initially, but trust me, the law of sines, even the ambiguous case for the law of sines, is pretty easy to deal with as long as you do what I'm telling you to do, which is build a table. And you'll see it in action in the next video when we actually start filling out triangles.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Just listen close. Don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.